There are 5 major families of microcontrollers manufactured by STM, but only one is qualifiable as an IoT device, the wireless series. We briefly describe first all families and then get a deeper overview of the wireless family. The high-performance series with CPUs based on the Cortex M3 up to Cortex M7 and clock signals up to 550 MHz is designed for high-end, computationally demanding applications such as digital signal processing, including real-time video and image processing. Most STM32 performance chips can have a wide range of powering voltage between 1.7 and 3.6 volts. The low end of the family is a constrained STM32 F2 with ARM Cortex M3 running up to 120 MHz. It includes up to 128 KB of RAM and up to 1 MB of flash memory. It implements almost all communication protocols, including Ethernet, ADC and DAC converters, and various hardware timers. Other family members are STM32 F4, F7 and H4. The top of the performance family is the STM32 H7 system on chip, which has a core based on Cortex M7, clocked up to 550 MHz. Some versions are even double-cored and have an additional M4 Cortex core running at 240 MHz. The built-in RAM is between 564 KB and 1.4 MB. H7 can work with a flash of up to 2 MB. It implements almost all known wired protocols and can easily integrate with most peripheral devices. It also has a hardware-accelerated JPEG codec, ChromArt graphic acceleration engine, and a single or double precision hardware floating point unit. Mainstream series balanced performance and energy efficiency and applies to various not-so-complex devices. The family of its low includes STM32 system on chip with CPU architecture ARM Cortex M0+, clocked at 48 MHz, some 6 or 12 KB of RAM, and 16 or 32 KB of storage. It has basic embedded systems connectivity, including SPI, I2C, I2S, and UART. There is also an analog-digital converter. Other family members are STM32 F0 and G0, F1 and F3. On the top of the family, there is a recent STM32 G4 chip with ARM Cortex M4 on board and running up to 170 MHz. It has up to 128 KB of RAM, up to 512 KB of flash, and various connectivity protocols, including Quad SPI for RAM extension and even USB-C with power delivery. It also provides multiple analog-digital and digital-analog converters. The G4 chip has built-in FPU and DSP features, example, fast Fourier transform. It also has an ART graphic acceleration built-in. The low-power series of STM32 devices are energy efficient and oriented for constrained battery-powered applications. It contains STM32 L0, L4, L4+, L5 and U5 chips. The most constrained chip, STM32 L0, runs Cortex M0 at 32 MHz and has up to 20 KB of RAM and up to 192 KB of flash memory. The system on chip has dynamic voltage scaling down to 1.8 volt for advanced power management scenarios. Even if constrained, it still presents interesting peripheral and interfacing options such as a 12-bit analog-digital converter with a throughput of up to 1.14 million samples per second, a 12-bit digital analog converter, a built-in 7-segment LCD driver, and many more. On its high end, there is a recent STM32 U5 system on chip, based on the Cortex M33 with DSP and FPU clock up to 160 MHz with up to 2514 dual bank RAM and up to 4 MB flash storage. It includes comprehensive interfacing options, such as cameras, SDMMC cards, readers, DSI, and octa-SPI. STM32 is known for its industrial-grade chips, which are more CPUs than the system-on chips because they require external RAM, flash, and I/O controllers. Still, it is an exciting family of chips such as the MP1 series, which can run Linux and Android and has a 3D acceleration unit and neural processing unit. Those chips are based on ARM Cortex A7 and Cortex M3 cores. There is also an SPC5 series explicitly designed for the use in automotive industry, which uses PowerPC architecture instead of ARM. Finally, the wireless series presents built-in connectivity. Commonly, the main CPU is assisted by another core that implements and handles radio communication.